I'm just going to dive straight in. It's as Christian mentioned, it's optimizing your data vault data warehouse on Snowflake. And that's the Snowflake Cloud Data Platform. So we're going to be talking about two separate topics that overlap quite well. So that's Data Vault and Snowflake. And the content of this talk and the demos is actually based on a series of blog posts. Before I get into that, just very quickly, as Christian mentioned, I'm a cloud data architecture consultant, been delivering data solutions to clients for 21 years. I'm also an associate faculty lecturer at the National College of Ireland. I'm SnowPro Core certified, Data Vault 2.0 certified, and based on my Snowflake community contributions, I'm a Snowflake data superhero. So in terms of the content, this is based on a series of blog posts by Kent Graziano. And Kent is on the call. Kent is, his handle is the Data Warrior. He's the Snowflake Chief Technical Evangelist. And Kent is also a Data Vault Master. So before I get into the detail, Kent, would you like to say a few words about the blogs or any initial thoughts?
No, Dan, I think you're going to cover it well. Thank you for turning my thoughts into this presentation and educating a wider audience. I think it's great that we have these meetups, and I'm very grateful to have someone other than me talking about Data Vault on Snowflake, honestly. It's great. We need more people talking about it. I'm glad you've taken up the mantle. And I'm even wearing my Data Heroes t-shirt for you today. So, have at it, man.
Great. Okay, thanks, Kent. So the series of blog posts, there are 4 of them. And what you see here is a summary. So the initial blog post, it's support multiple data modeling approaches with Snowflake, and it asks the question, can you deploy a data vault on Snowflake? And of course you can. And it references what are called multi-table inserts and hashing functions like MD5. The second blog talks about optimizing the data vault architecture on Snowflake. It refers to the different types of keys, sequential keys in Data Vault 1.0, natural business keys, hashing keys in Data Vault 2.0. And from a Snowflake perspective, how can you really get into parallel data loads? And that follows on nicely from the first blog post. The third blog post goes a bit further in terms of the parallel data processing aspect, and it uses something called, or talks about something called virtual data warehouses on Snowflake. And then the final blog post talks about big data on Snowflake. So that's semi-structured. And what we will look at here in terms of this talk is JSON processing in a data vault on Snowflake. I'm going to talk very briefly, just in case you are new to Snowflake or new to Data Vault. I'm going to take a couple of minutes to introduce those topics, and then we'll get into the deeper content. So beginning with Snowflake, it's a cloud data platform. And the architecture covers is at a high level, can be split into 3 parts. The database storage. So that's where the data sits as a starting point. And because Snowflake is cloud agnostic, this could be S3, AWS, S3 buckets. It could be Azure storage. It could be Google Cloud Storage. Once the data is being processed, so you're running DML like select, update, delete, insert, anything like that, the data gets processed in what are called virtual warehouses. And these are clusters of compute nodes. And we'll go into that in a little more detail. And the third layer is the cloud services layer. And this is like the manager of everything. It manages, as you can see, authentication, infrastructure, metadata, and all of this, even though you may be processing the same data across different compute nodes, the cloud services layer ensures ACID compliance. That's ACID compliance. And this platform is also highly scalable. And a big part of that scalability is the virtual warehouse aspect. It's a warehouse, so the storage is columnar, and that's as opposed to row storage. This would be conceptually separate from the storage you might find in Apache Cassandra, but it's columnar as opposed to row storage. ANSI SQL support. So the barrier to entry is managed. It's got some pretty cool data sharing functionality. We won't be looking at that today. It's got some pretty cool data cloning functionality. We won't be looking at that today either, but what we will be looking at is the scale up, scale out nature of the Snowflake Cloud Data Platform and the MPP clusters, those compute clusters. MPP, massively parallel processing. So you may be running a select across more than one node, for example, more than one processing node. With those virtual warehouses, you can separate your load. So you can have one virtual warehouse, which again is a cluster of compute nodes. And you could use one virtual warehouse for ETL or ELT, a separate one for data science, a separate one for BI reporting. And again, the cloud services layer ensures ACID compliance. Everything is encrypted at rest and in transit. There's all kinds of query optimizations that take place. And there's a micro-batching aspect to Snowflake as well. And that's called Snowpipe. So that at a very high level, that's your crash course to what Snowflake is. So here's crash course number 2. What's Data Vault? All right. So Data Vault, as defined by Dan Lindstedt, the inventor of Data Vault. I mean, there's a lot here, but I'm just going to go through it quite quickly. It's a detail-oriented historical tracking. And the moment you see historical tracking, chances are there's a data warehousing aspect to the discussion. So it's got normalized tables and supports one or more functional areas of the business. So what that infers is lots of data sources, right? Data warehouses specialize in managing lots of data sources. Data Vault specializes in the actual management of that data itself in terms of normalization and so on. So as the definition says, a hybrid approach encompassing the best of breed between 3NF star schema. It's flexible, scalable, consistent, and adaptable. And there are 4 keywords there as to why you might consider Data Vault in terms of the data modeling aspect of Data Vault. It's flexible, scalable, consistent, and adaptable to the needs of the enterprise. It is a data model that is architected specifically to meet the needs of enterprise data warehouses. There's one other thing I want to mention about Data Vault before we look at the detail. There are 3 core components: hubs, links, and satellites, right? Hubs, links, and satellites. And whatever kind of data modeling you're doing at a raw Data Vault level, and I'll explain what that term means a little later, you're always going to use one of these 3 components. There are different types and so on, depending on what you're doing. But at its core, these are the 3 components. And if we go back to the definition here, one of them is consistent. So there's a consistent aspect to the design. It's repeatable, and it's quite intuitive and adaptable, right? So if you need to add something because of the nature of hubs, links, and satellites, it can be a little bit easier, so less overhead in terms of making changes as your data vault, data warehouse evolves. Hubs, they are like nouns, people, places, things, events, right? Links, associate hubs. And satellites describe their attribution. For example, if a hub is a customer hub, a satellite is used to describe that customer hub. For usually by data source, you usually use a satellite by data source. So for example, customer name, customer date of birth, customer preferences, right? A satellite is a great way to capture those attributes. So in the data vault, you have 4 core aspects in terms of the data model, which is hubs, links, satellites, okay? They are your 2 crash courses, Snowflake and Data Vault. All right, so let's get into the detail, right? In terms of the demo, an easy way to start actually is you get data sources out of the box with your Snowflake trial, right? So if we have a look at, and by the way, there are different interfaces with Snowflake, but I'm going to use this interface that you see right now because everything is here, and it's pretty intuitive. It makes it easier to demo. Okay, so those sample data sets that you get with Snowflake, and by the way, on your left in this Snowflake interface, web interface, is your Object Explorer. Then as you can see here, you've got your SQL worksheets, and I've got a lot of different worksheets open here. You've got your databases if you want to share data, your marketplace if you want to get your hands on data, warehouses, those virtual compute nodes, which we look at a little bit more later. Query history. Everything in Snowflake gets audited. Coincidentally, or maybe not, Data Vault, one of its core aspects is auditability. So not only will a Data Vault capture its history, you can, from a Snowflake perspective, look at all the DML, activity, and so on. So this is your 3rd crash course, by the way. This is your crash course in the Snowflake web interface, the current one. There's a newer one as well, but for this demo, we're going to use this one. All right. The sample data sources are in this aptly named Snowflake sample database. You have some TPC data sets, and you have some weather data. The TPCs, the Transaction Processing Performance Council data sets, right? Often used for benchmarking. We're going to look at some of the TPCH data sets, so for decision support for big data. And we're going to look at the weather data because the weather data has JSON. So this, for all intents and purposes for this demo, we're going to use data from our sample database, right? A TPCH data set and a weather forecast data set. And with the weather, we're actually going to see, we're going to look at the weather forecast for Munich, and we're going to see if it actually matches with the actual weather today. Okay, the data model, because Data Vault, a key part of Data Vault is data modeling. So keeping the sample data sets in mind that we get, and again, for the purposes of this demo, if you can imagine these tables, these are schemas, by the way, but you've got lots of nice tables in here. If you could imagine these as, or assume these are in a staging area. So we've already loaded the data onto the Snowflake platform. Now, before we go any further, there are different approaches to loading data into Snowflake. You've got what are called stages, external stages, so you can hook right into S3 buckets, Azure storage, Google Cloud Storage. You've got Snowpipe, which is the micro-batching aspect. You've got Apache Spark connector. You've got Kafka connector. There's all kinds of connectors. But for the purposes of this demo, if we're going to assume that the data has already been staged on Snowflake, and we want to get that into our Data Vault data warehouse, okay? So, the data models. I'm using SQL DBM for the purposes of this demo, right? SQL DBM, and it's an online data modeling tool, and its usability is way up there. Okay, we have 2 data models. Keeping in mind the source data sets we just talked about there, the TPC data set and the weather data set. At a high level, we're going to look at some supplier data, the different hardware that supplier supplies, and the inventory of a particular supplier. So the blue squares here, they're the hubs. They're the people, places, things, events, right? So in this case, parts are a thing. Inventory, in this case, I've assumed it's an event. And the supplier is obviously, well, it could be an organization, it could be a person. So they're the core, or they're the starting point of your data model in terms of data vault here, right? Those 3 blue hubs. Now we associate those 3 hubs in this context, from this perspective, using a link, which ties together the supplier, the parts, and the inventory, right? So we talk about hubs. That's a link in your data vault. And by the way, these squares are just tables. This is a physical view, and we will see a bit more in a moment. These guys on the periphery, these guys are what are called satellites. And that's where the attribution is. So if we have a look at the physical model, the columns in the physical model, should I say, you can see that if we take the supplier hub, we have the typical attributes you would expect in a data vault hub. You have the business key, and that could be a source column, it could be composite columns. We have when that data was loaded into the data vault, not when it was extracted from source, when it was loaded into the data vault. Where it came from, so you're tying in with the auditability. And if we look at the data vault supplier satellite, we have different attributes. We have the supplier name, address, phone number, account balance, and country code. And we've other data attributes here as well. We have a hash diff attribute, and we use this to check have the values changed from an attribute perspective. Now, there's a couple of things to mention here, and I'm going to dive into one of the blogs actually. Oh, sorry, before I do apologize. The other data model is how we manage our JSON, how we manage our big data, our semi-structured data. So this is a separate model coming from the weather data set. And we have one hub, and that's an event, which is a weather forecast. And that weather forecast has attributes like temperature, what day the weather forecast applied to, and so on. So if we have a look at the columns, again, you see this consistent pattern with the hub. When it was loaded, where it came from, and a business key. That's it. You have here the primary key as well. I haven't called it a hash key, but this is typically where you would put a hash key from a Data Vault 2.0 perspective. A business key could also be used here. And I've designed that model with that in mind. As it evolves, I may remove the business key, but that's not for now. On the weather forecast side of things, I'm just going to draw your attention to this very briefly. There's a Snowflake data type called variant, which I mentioned, and that's what sits right here. So we're going to revisit this in a little while, but let's go back to the TPC data set, supplier, part, and inventory, right? So if we just briefly go to one of Kent's blogs, right? What you see here is the Data Vault 1.0 model for loading your Data Vault. So traditionally with warehouses, when you have a table in your warehouse, you traditionally and typically would add a surrogate key. And what's a surrogate key? It's an identifier that's specific to the warehouse. Your business users typically won't know what it means, and it's usually a seeded incremental column in your warehouse, or seeding of that column takes place on the way in. So if you have 10 rows, you automatically say row 1, 2, 3, 4, 5, 6, 7. You give each one a unique ID or something of that nature. So with 1.0 and traditional data warehousing loads, you have to look at the hierarchy. And what I mean is, if we go back to the model here, right? This is the primary key. There's the foreign key. That's the primary key, foreign key, primary key, foreign key, primary key, foreign key. So what does that infer? That infers there's a dependency and an order in which you need to load your warehouse, right? So in other words, you got to load with the traditional approach, load hubs first. Now when this has its identifiers, load your satellites. Load your links after you've loaded your hubs. And if you are putting satellites on your links, they get loaded last. So there's an order here, and there's lots of lookups as well, and it can be expensive in terms of database processing, right? So the approach advocated in this blog, is to go with business keys, or take it a step further, go with hash keys. So in other words, if I go back to the model for a moment, forget about surrogate keys. That's the first thing, right? What you're doing is, let's take the supplier hub again as an example. You're saying, I'm going to uniquely identify each row in the supplier hub using business keys. So in other words, I'm actually going to know in advance what the unique identifier per row is. And if I know what the unique identifier per row is for the primary key, I can derive and know in advance what the foreign key value is going to be, right? So that's what's inferred here. So if you know the keys in advance, you can load everything at once, right? You can load everything at once. And Snowflake has support for multi-table inserts, right? Multi-table inserts. So what that looks like is, and let's go back to the model again for a moment. With the traditional loading approach, you would need to load this hub here first, supplier. Then you can think about your supplier satellite. Then you can think, and so on, your link and all the downstream dependencies. But if you know upfront what your business key is going to be and your primary key is going to be, for example, using a hashing approach, then you can load everything at once. So I'm actually using an insert all command here to load those 3 data vault tables at once. Okay, so I take this. Actually, I'm just going to run all of the queries. I'll walk you through them very quickly. And what I'm doing here is I'm loading the supplier hub satellite. I'm using the same pattern to insert all, the multi-table insert to load the part hub and part satellite at the same time in the same transaction. And likewise, I'm loading the inventory hub, satellite, and link at the same time in the same transaction. Now I'm using an override here because I'm truncating the table each time up front, but that's from a testing perspective. In a later script, we'll see how using the hash diffs can be used to work out, do I need to do an insert here? And what's more is, it's only the insert command, right? No updates here. We're not doing any kind of slowly changing dimensions. We're not doing any kind of updates for 2 reasons. One, you just want to, you don't want to have any dependencies in terms of your updates. And 2, updates, deletes are more expensive. Snowflake loves inserts. Of course, Snowflake can do updates. Of course, Snowflake can do deletes. But because of the storage, the underlying storage with Snowflake, Snowflake loves inserts. So this is like a match made in heaven in terms of the data vault approach plus the Snowflake database engine. Right. So I'm just going to run all these now. And it's because I've got this override command, it's going to truncate all our tables, but that's going to load them here. While that's running, what I did earlier was I designed my model in SQL DBM, and then it's very straightforward to forward engineer your data model. I click here, I've generated my DDL, and then I apply that to Snowflake. So they were the steps to get the model from SQL DBM into Snowflake. So, okay, cool. What we've done here is, in the space of 7.7 seconds, we processed 8,000 hub rows, likewise satellites, and we've got 8,000 link records. And that actually applies to the inventory, the last one. But that's our data vault populated on the first instance, right? So the primary point here is you're not using surrogate keys. You are determining the primary key up front. It's based on a business key from the source system. And you're also using the insert all approach to load your data in parallel. Now, I do want to go back to the data vault for one moment, because it's important to keep in mind, there's a sentence here. This is a general tip, and John Giles' book, The Elephant in the Data Vault, it's a great reference in terms of how to design an enterprise data vault from taking into account the top-down approach. You need to get your semantic and grain right. Okay, I'm not going to spend a lot of time on this because I don't have a lot of time. But the bottom line is, if you've defined something as supplier, make sure it's a supplier. Get the definition of supplier. Because when you start integrating more data sources, they might have suppliers, but they may have different names, and the definition, the wording of the definition might be different. But you've got to get the semantics right. Do they mean the same thing? And likewise, the grain. So you could design your data vault to have supplier. You could go up a grain and say organization or party, and you could go down a grain. So you got to get your grain right in terms of your design. So it's well worth keeping that in mind. All right, let's go back to Snowflake. So next up is those virtual warehouses, right? I'm going to create them using SQL, and then we're going to have a quick look at them to see what they actually represent, right? So it's very straightforward to create them, and it's very straightforward to use them, right? I'm just going to run this SQL, and then I'll take you through the dialog. Actually, that's the easiest thing to do. Okay, in the Snowflake dialog, you have this warehouses button. All right, I have created 4 warehouses, which are clusters, the compute nodes. Let's have a look at one of them, right? And this is where the elasticity of Snowflake is really articulated, okay? So first up, this warehouse, this cluster of compute nodes currently is an extra small. T-shirt sizes, right? You can say what size you want your compute node cluster to be. You can say I want it to be a 1. So, sorry. The credit cost here, it's credits per hour. That's how Snowflake bills, and you only pay for what you use. The credits are also synonymous with how many nodes you have in your cluster. Now it's abstracted here because the thinking is to make it as easy to use, or to make it easier to use, right? So you don't have to get into downtime. You don't have to get into plugging in wires and more blades and less blades on your rack in terms of the server room. Just pick out what size you want. So currently X small, that's 1 credit, and that's also 1 compute node. If I go up to a medium, that's 4 compute nodes, right, in that 1 cluster. So if I throw a query at that, depending on the volume of data, the type of query and processing and all the rest, Snowflake will decide how best to process that data set. I've also got this here, you see this? Maximum clusters, minimum clusters. So what does this mean? This means that if this 4-node cluster gets overwhelmed, if there's lots of queuing, then Snowflake will automatically say, oh, hang on, I got some queuing here, got some queries waiting. I'm going to spin up another cluster. automatically. And likewise, if the queuing eases off, Snowflake will automatically notice that and say, okay, second cluster no longer needed, spin it down. Really elastic. So there are your virtual warehouses, and there's two other little settings here: auto suspend, auto resume. In other words, if your cluster is not doing anything for 1 minute, shut it down, stop billing. But if a query is thrown at that cluster, wake up again, auto resume. Okay, so that's a brief introduction to virtual warehouses in Snowflake. Now back to the blogs, right? This is another diagram from one of Kent's blogs. And what's being inferred here is, look, take the parallel loading a step further. Why not? Because you can split out the processing of hubs from satellites and links, right? Because you can infer the business key or the primary key, be it a hash key or otherwise. Well, why not just use separate compute nodes? Why not use separate virtual warehouses, separate virtual clusters, right? So that's what I'm doing here. I've actually created a virtual cluster for satellites, separate one for links, separate one for hubs. And bear in mind, Snowflake is ACID compliant. So just because one compute cluster makes a change does not mean the other compute clusters aren't aware of it. The cloud services layer takes care of all that. So what I've got here is 3 scripts. I'm going to run the hubs on one virtual cluster, run the satellites, populate them on a separate virtual cluster, and the links on a separate one again, right? So I'm telling Snowflake, if you wouldn't mind too much, please use this warehouse for loading hubs. You see this use statement? Use warehouse ETL hubs. And I'm telling Snowflake here, for satellites, please use the satellite cluster. I've designed it. There's not, you can actually throw any kind of queries at this cluster, but the business case in this instance is processing satellites. And I have a third virtual warehouse for links, okay? And looking briefly at the SQL, starting to use the hash diffs. So and I'm just going to go back to the data model for a very brief moment. On each satellite, for example, you've got a hash diff, which is a hash of the different attributes. And rather than when you're loading a satellite checking, look, where part name equals source part name, or part manufacturer is not equal to manufacturer and so on, just check the hash diff. If there's a change in the hash, just insert a new row. Okay, so what we're doing here is, as mentioned, use this virtual warehouse to load the hubs. And if we scroll briefly through the code, this loads the part hub, this loads the supplier hub, this loads the inventory hub. And likewise with the satellites, we have the supplier satellite, but we're also checking the hash difference. If this MD5 hash of the attributes on this supplier satellite already exists in the supplier satellite, well then it's already there. We don't need to load it again because there is no material change. So we're going to load the hubs in one virtual warehouse, the satellites in another virtual warehouse, and the links in another virtual warehouse. So here we go. And bear in mind, we've already loaded them using the multi-table insert approach, but nonetheless, let's just run the scripts and let's see if there should not be any change actually. And I'm throwing all these queries at Snowflake at the same time, or as fast as I can click on the run button. While that's happening, let's just have a look at the warehouses. See the status here? These are all started because they've woken up. The queries I've executed have woken up the virtual warehouses, and now they're running. Okay, they've finished running. And after 1 minute, if no other processing occurs, they will stop billing and go into a suspended state again. So if we briefly look at one of the data vault tables here, we can see that, let's have a look at the supplier satellite. There's all our columns. That's our primary key, which is a hash key, which was derived from the business key. When it was loaded, when it was loaded into Data Vault, not when it was extracted from the source system. We have our different attributes. And columns, address, phone, account balance, nation code, they're all using the hash diff, okay? To make it easier in terms of inserting. All right. So now we've looked at multi-table inserts, we've looked at virtual warehouses, we've looked at parallel loading of your hubs, links, and satellites, and now we're going to look at the semi-structured side of things. So let's actually briefly go back to our big data vault. Now, this is again just for demo purposes, but it will give you a sense of what's involved. And in the final blog in Kent's series of optimizations on Snowflake, data vault optimizations on Snowflake, he talks about a discussion with Dan Linstead about how best to manage semi-structured data on Snowflake. And the conclusion is twofold. One, Snowflake has this variant data type out of the box, right? That manages, or can be used to manage Arc, Avro, Parquet, XML, JSON, right? That's the first part of the conclusion of that discussion between Kent and Dan. And the second part of that discussion conclusion is, well, let's say you've got a JSON document. Why do you use JSON? Because it's flexible, it's schemaless, or more accurately, schema-on-read, right? So let's say you've got 100 attributes in your JSON document, but you're only interested in 5 of them right now. Why make them relational when you only need 5 of them and chances are things are going to change? So based on that, just load the JSON document as is into your data vault, and then later downstream start parsing the JSON, right? So how does that look? If we look at so we've obviously forward engineered those 2 tables, deployed them in Snowflake, and similar approach. I'm using an insert all, and I'm telling Snowflake to use this warehouse. But in this case, we're processing about 15 gig worth of JSON documents, so I'm scaling up to a medium virtual warehouse, which is 4 node. All right, I'm going to run that, and then I'm going to scale back down again, back to a 1 node, extra small. All right, here we go. Now, while that's running, because that takes about 2 to 3 minutes, how do you parse the JSON, right? So you've gotten it into the warehouse, you've gotten it into your data vault, but what do you do next, right? Now, if you're deriving data from a data vault, so the typical, when data first lands in a data vault, it's referred to as the raw data vault, right? If you're deriving data from that, if you're doing aggregations or anything like that, typically that next downstream aggregation step or whatever it might be, the derivations, is typically referred to as the business vault. Now, it's best to look at the business vault and the raw data vault as concepts that can easily exist in the same database, and often do, because you may find that you have business vault data that sits nicely in the raw data vault structure, right? So you may downstream score customers in terms of credit risk, and you want to store that back in the customer satellite. Okay, so here you have an example of parsing JSON in Snowflake, right? Oh, Let me just show you the JSON very quickly. So this is an example of the JSON in that sample data set that you get with Snowflake. Now, this data set's deprecated in some regions. It may not be available, but nonetheless, for this demo, we're going to use it. And you can see there's a city. It's got different attributes like city name and country and so on. And this is how you parse it. There's some key commands here. Lateral flatten, that's very important, okay? So you're taking those embedded arrays and hierarchies within your JSON document and you're making them relational. So flatten actually takes those, let's say they're comma separated lists or whatever they might be, makes them relational. And lateral associates it with the information around that, let's say array or whatever it might be. So I'm parsing out country code, city, when the forecast applies to, I'm getting the temperature, average, the minimum, the max, and a weather description, okay? Now, I'm going to take this a step further. It can take a little bit of time. It's still JSON, so I'm going to turn that into a materialized view. So this is a Snowflake optimization, and conceptually, it's like you're physicalizing the view. But each time the underlying data changes, Snowflake notices and changes the data in that materialized view as it needs to. But and by the way, we're filtering as well on the city of Munich. Okay, so I just need to get the right warehouse. We go small on this. I can just check up here as well. You've got this drop down. Definitely our compute warehouse is now small. That's a 2 node. All right, let's go with the materialized view here. Create a replace materialized view on a small warehouse. And here we go. I'm just conscious of time. So let's go back and check that the loading of the JSON in the first place has completed. And that took, okay. Yeah, in the script I said switch it to an extra small, but then in the other script I scaled it back up to a small. So as you can see up here, the compute warehouse, the virtual compute node cluster is an S, and that's a 2 node, which is what's running in the business vault. Okay, the business vault materialized view has been created successfully. So let's have a look at the forecast for Munich. Okay, now this forecast was made just yesterday. So the data set, the sample data set does get updated from time to time. So if we look at, it's a 14-day forecast and today is the 22nd. So let's have a look at what this data set said the 22nd was. Right? So about 22 degrees, minimum of 13, maximum of 22. And light rain. Christian, what's the weather like in Munich? Is this forecast?
Yeah, sounds about right. Sounds
oh,
about right.
Fantastic. Brilliant. I had a look on AccuWeather and it had a thunderstorm warning in effect, and I thought this forecast is way off. But glad to hear that the weather's not so bad. Okay, so to summarize, we had a look at example data vault models in SQL DBM. We talked about hubs, links, and satellites. We talked about using business keys instead of surrogate keys and the potential of hashing those business keys. We talked about MTIs, multi-table inserts, and parallel loads. We talked about hashing. Oh, Snowflake it supports MD5 hashing. It supports SHA-1, SHA-2. It's got its own hash, HASH function. So it depends on what hashing approach you want to take. And yeah, we talked about business keys. I didn't talk too much about micro-partitioning. I have about 3 minutes, so I'm just going to elaborate a little bit on this point, which is that one of the cool things about Snowflake is that you don't have to manually partition your data. And this is very important because particularly when it's MPP, when it's massively parallel processing, when you're using more than one node, you need to be conscious about how is my data getting distributed across the nodes, right? So you're looking at partitioning of data, distribution keys and whatnot. Snowflake does all that for you. It does it as you're loading the data onto the Snowflake platform. It splits the data into, as mentioned, columnar storage, and that's compressed as well. And it's usually 16 meg parcels of data, and they're contiguous, so they're sitting right next to each other on disk, but it varies. It depends on lots of different things. And when that data is loaded into Snowflake, it tracks things like ranges, min-max values, different statistics on your data. So it can do what's called pruning quite effectively. And I'm going to show you a very quick example of pruning, actually, if we have time here. If we have it, just bear with me. So this is the Snowflake audit history, by the way. Let's see if we have it. I'm on the materialized view, so let's see what it does. I'm looking at the profile of the query. So Snowflake works out. Okay, no, it's already worked out lots of answers. We won't see pruning there. But basically, if you've got like 1,000, if your data is spread across 1,000 partitions on disk, Snowflake can work out, depending on what the contents are of the where clause in your select, assuming you have a where clause. It can determine, well, because I have all this metadata on the micropartitions, I don't need to scan all 1,000 micropartitions. I can prune and scan 10 of those micropartitions, or whatever it might be. So that's a big optimization plus with Snowflake. So back to the conclusion. We also talked about splitting the load across virtual data warehouses. We talked about managing semi-structured data in your data vault and the Snowflake variant data type. And we talked briefly about the business vault in terms of that layer of derivation. Conceptually, it sits above or downstream from the raw data vault. And that's where you start aggregating, deriving data and making it more user-friendly. And a business vault would also contain logic that's typically used a lot. Okay, so that's the conclusion. I just want to mention 2 books. I referred briefly to John Giles's The Elephant in the Fridge. This is a great book. If you want to read about and learn about how best to approach a data vault delivery from an enterprise perspective, from a top-down perspective. As the polar opposite is source designed data vaults, which seriously, you literally see the velocity of your sprints going down, slower and slower if you take that route. And John talks all about how to manage the risk and get a business view, an enterprise view that feeds into a really solid data vault design. The second book is Building a Scalable Data Warehouse with Data Vault 2.0. Dan Lindstedt, Mike Olszymka. And if you want to learn about not only the data vault, data modeling side of things, like the different types of links hub satellites and the hashing approaches associated with them. There's some nice hashing algorithms in there. Hashing patterns, should I say? But also in terms of tying in the value of data as an asset and things like that, then that's a really good reference as well. So there's some links here that tie back to Kent's blogs. And with that, I'll say, herzlichen Dank, ich bedanke mich. And are there any questions based on the content?